In this presentation, I am going to explain the meaning of electromotive force. Electromotive force, it is shortly called as EMF. This electromotive force concept, it is often introduced in the current electricity chapter. Here, what is EMF? That is very important. Are you clear? Often it is used in the current electricity. The term electromotive force, that must be clearly understood. Here, that is somehow related to the battery or cell. Are you clear? So here I have taken different kind of cells. This is a cell used in the two-wheelers. This one is able to provide, this one is able to supply larger amount of EMF. Here there are two ends, one is positive end and another one is negative end. Usually that positive end, that is taken as high potential end. The negative end is taken as low potential end. So in between the positive end and negative end, there is a potential difference. So the potential difference across the two end of the battery is called as EMF. Are you clear? The cell is not connected with any other component in the circuit. The cell is free across the positive end and negative end. If you measure the potential difference, that potential difference is called electromotive force. Otherwise, it is shortly called as EMF. If it is a original one, if it is a new one, the EMF of the cell is 12 volt. Are you clear? If it is new one, brand new one, the EMF of the original and new one is how much? 12 volt. This cell is already used for several hours, so it becomes old. Therefore, the potential difference across the two end of the cell will be very weak. So definitely EMF will also be very low. Now I am going to measure the EMF with the help of the digital multimeter, digital voltmeter. This EMF is a driving energy. Are you clear? That one is capable of, with the help of that electromotive force alone, what will happen? The electron, they are supplied from one end of the, from the negative end of the cell to positive end of the cell when they are connected, when the two ends are connected by means of wire and other components. So the current is able to flow from one end to, that is from positive end to negative end, conventional current that flows from positive end to negative end only because of the difference in potential. If there is no difference in potential, if there is no EMF, if there is no potential difference across the two ends, current it won't flow. Because of the potential difference alone, current is able to flow. That potential difference across the two ends is called EMF. Are you clear? So EMF is nothing but it's a work done. Are you clear? EMF is not a force, though it is called as force, it is not called as, is it clear? It is not said to be force. In the name, is it clear? It is named as EMF, but actually it is a work done. What for that work is done? The work is done to drive the electron from one end to another end. With the help of work done, the electrons are pushed from negative terminal to positive terminal, and conventional current it starts to flow from positive to negative. Are you clear? So it's a driving energy. EMF is nothing but driving energy. The driving energy is obtained from this cell. So the potential difference across the two end, I am going to measure, that is nothing but EMF. Now we will measure the EMF of this cell. Okay. Now the probe of the red probe must be kept in positive terminal, black must be kept in the negative. Just you measure what is the EMF of the cell. 9.9 volt. 9.9 volt is the present current EMF of the cell. It shows that the cell is already used, it becomes very weak. Are you clear? So this is the EMF of this cell which is used in the two-wheelers. Are you clear? If it is new one, that multimeter, that digital voltmeter will show 12 volt. So this is the present and current EMF of the cell. I hope you have understood what is the meaning of EMF. Now I am going to measure the EMF of other cells. Now I will keep it aside. Now I am going to measure the EMF of other cells. So this is a cell. It's another kind of cell which is working with the help of chemical action. Here also there are two terminals. positive and negative. This one also becomes very old. Now we will check it up. Okay, this is the positive terminal, that one is the negative terminal. Now I am going to measure the EMF of the other cell, next cell. Are you clear? So red should be kept in positive end, the black probe to be kept in negative. So what is the EMF now? 0.06. Actually, the original EMF of this cell is 9 volt. It becomes very weak. It is not able to be used. It should be thrown off. But you have to know that is clear. What is the present EMF of the cell? It shows that it has got it has almost lost its driving energy. The EMF is very low now. It is not able to supply any electricity. It is not able to supply any current. That's why we are throwing this cell into the dustbin, because it becomes useless, because EMF is almost zero. Are you clear? Now I will measure the EMF of this one. Usually this kind of cells, they are available in the market. The original and the fresh, in the case of fresh cell, the original EMF is how much? 1.5 volt. That is the original EMF of the cell. Let's measure what is the EMF of the cell now. So we have to keep it like this. The positive end and negative end both have to be kept. Both have to be connected with the probe. Look at that. The EMF of the cell is 0.88 volt. The original EMF is 1.5 volt. Almost it has lost its half of the strength, half of the energy. It is also not able to be used in any electric and electronic appliances. It should be thrown off. You can't use it even in the watches or in clocks. Understood? So the EMF of the cell is how much? 0.88 volt. Let's go to the next one. Now you have to understand that due to aging, if they are continuously used, what will happen? They will be losing their capability of supplying the electricity. It shows that the EMF, it becomes very low. Now I am measuring the EMF of the next cell. Now the EMF of the next cell is 1.2 volt. Here the EMF is somehow better. This one could be used for few more days. Are you clear? The EMF of the cell is how much? 1.2 volt. Let's go to the next one. Another cell. Here the EMF of this cell is 0.79 volt. The EMF that must be measured only in terms of volt. Are you clear? The electrolyte which is stored up within the cell, almost it becomes dried. That's why they are all called dry cell. Inside ammonium chloride pulp is filled up. Are you clear? If the ammonium chloride pulp, if they become dried, what will happen? The chemical actions will be stopped. So automatically the EMF of the cell also will become very low. Here the EMF of the cell is 0.79 volt. Here this cell also has lost its life. Okay. Now I am going to show you the last cell. The last cell is, though it is small, its EMF is also 1.5. This one could be used for longer hour duration. Look at that. The EMF of the cell is 1.36. Though it is small, this one is able to supply the electricity current for longer time because EMF is more. So 1.36 is the EMF of the last cell. Are you clear? This one could be used for few hours, few days. These kind of cells, they are very much used in the case of remote control. So it depends on the size, depends on the EMF. The utility, it differs. Understood? Now I hope you have understood what is EMF. So whenever you call the term, whenever you use the term EMF, we have to understand that the potential difference across the cell is called as, what is this? EMF. When it is not connected in any electrical or electronic circuit, in the open circuit, if the potential difference is measured across positive and negative end, that is called as EMF. That is a driving energy, that is a work done, which one is capable of driving the electron from one end to another end. With the help of EMF, we can come to a conclusion that whether the cell can be used or not. Are you clear? If the EMF it becomes very low, means that cell it will be losing the capacity of supplying the electron from one end to another end. Once the electron flow is stopped, what will happen? The appliance it won't function. The supply of electron, the flow of current, the electric current, the flow of electric current, everything that depends on the EMF. If EMF is more, the current flow will be more. If EMF is less, the current flow will be very less. Understood? So the EMF of the last cell is how much? 1.36. Okay, thank you.